Okay, we're going to start second semester by finishing up topic 4 so far. And when we test over chapter 4, we're going to test over the entire chapter. So far, we've talked about how we solve a system of equations. A system of equations is when we have two or more equations in the same system, and we're trying to find that one solution, if it exists, for both equations or however many equations there are in the system. We're finding the one solution that works for all of the equations. So now we're going to transition to section 4.4. It says linear inequalities in two variables. So instead of having an equation, we're going to now start working with an inequality. It says that solutions of a linear inequality in two variables is all ordered pairs that make the inequality true. Just like our solutions for the system of equations was the ordered pair that made the equations true, we're looking for the ordered pairs, and there's going to be more than one, the ordered pairs that make the inequality is true. So example 1, it says tell whether the ordered pair is a solution to the given equality. Well, how do we do that? Well, keep in mind that every ordered pair is an x and a y value. X always comes before y in the ordered pair. So we're going to substitute those values into our inequality and see if it's true. So 0, 0 goes in, so 0 plus 0, 0 goes in for x, 0 goes in for y. Is that less than a negative 4? 0 plus 0 is 0. Is 0 less than negative 4? And that's a false statement. Okay, that's false. 0 is not less than negative 4. So we would say no, that is not a solution to the given equality. Don't leave your answer as false. Go back and say no, it's not a solution. I'm going to plug these values in. Notice that y is first. It says y minus x. My y value is the negative 4. And I'm subtracting my x value, which is the negative 1. Is that greater than negative 2? So if I do leave, change here, I'm leaving, making that plus. I get negative 3 is greater than negative 2. Is negative 3 greater than negative 2? That's also false, so I would say no. That ordered pair is not a solution to that inequality. And let me try letter C. As I plug these values in, I'd say 4 times negative 2 minus 7 times 4, is that greater than 28? Negative 8 minus 28, that's a negative 36. Is that greater than 28? Again, that's false, so the answer is no. Now, sorry that all of those were no. Hopefully one of those would have been true. But if this comes out to be a true inequality, where if you're going to write down true, then it would be yes, that is a solution to that inequality. Okay? Graphing inequalities, this should just be review for you. This is a less than sign. Okay, if the inequality points to the left, left for less than. If it's pointing to the right, that's a greater than. Okay, so make sure you know how to read those. This would be, if the line is underneath of it, you would say that's greater than or equal to. Okay, greater than or equal to. This is a less than or equal to. Okay, this is just a greater than sign, so if it doesn't have a line underneath it, it just means greater than. That means if it were equal, happen to be equal in that situation, it would be false. If it says greater than or equal to, then it's going to be greater than or it could be equal to. Just make sure you follow it. This is a less than sign, this is a less than or equal to. Okay, so when it comes to graphing an inequality, when it comes to graphing an inequality, we do the same thing as if we're graphing an equality. If this had said y equals 4x minus 3, how would we graph that? We can do a table of values, we can find intercepts, or we could use slope-intercept form. This happens to be in slope-intercept form. My y-intercept is negative 3, so that's where I'm going to put my first point. And I'm going to use my slope here of 4 over 1. I'm going to rise 4 and run 1. 1, 2, 3, 4, and run 1. Now, this is where we go back. This is how it's going to be different from an equation. I find the points to plot the same way I find the points as if it said equals. But now I go back. I've got an inequality here. And that inequality is just a greater than symbol. It does not say equal to. It just says greater than. And in that case, what you want to do is you want to use a broken line when you connect your points. okay? You're going to use a broken line as you connect them. It's broken because we don't want to include that line. We want to go right up to it, but we're not going to include it. So we use a broken line, and then we're either going to shade the ordered pairs on the left side of the broken line, or we're going to shade the ordered pairs on the right side. Because remember, we're looking for all the ordered pairs that are a solution to that inequality, and there's going to be more than one. So to figure out where to shade, you want to choose a point that's not on your line. 0, 0 is the easiest value to plug in. So I'm going to use 0, 0, and I can do that anytime 0, 0 is not on the broken or the solid line that we use here. So if I plug 0, 0 into that inequality, I would have 0 is greater than 4 times 0 minus 3. 0 is greater than 0 minus 3 is a negative 3. So is 0 greater than negative 3? That's true. So I want to shade the side that 0, 0 is on. It means all of these ordered pairs on this side of the line are going to give you a true inequality. Okay, look at example 3. Again, this is in slope-intercept form again. So I'm going to use my y-intercept to graph 1, 2, 3. Here's positive 4. It's going to be a point on my line. The slope of the line is negative 2 over 1, so I'm going to go down 2 and over 1. Down 2 and over 1. Okay, now this is where you got to go back and look at your inequality symbol. Since it says less than or equal to, it's got the line underneath of it, so that means it could be equal. I want to make this a solid line through there. Okay, when the line's under it, and it means it can be equal, greater than or equal to, less than or equal to, you're going to make your line solid. If it's just a greater than or just a less than sign, you're going to make your line broken like that. Okay, now I've got to pick a point that's not on this line. 0, 0 again is not on the line, so I'm going to plug in 0, 0. And 0 is less than or equal to negative 2 times 0. That's 0 plus 4. Is 0 less than or equal to 4? That's true. So I want to shade the side that 0, 0 is on. All of these points over here are going to make that inequality statement true. Okay, let's take a look at a couple others. Okay, when you just have one variable that you're looking at, recall this from an earlier chapter. If that had said x is equal to 5, what kind of line is that when there's just one variable? When the variable that's present is just the x, we have a vertical line. So it's going to go through 5 on the x-axis, and it's going to be vertical. Okay, I want to go back and look at my inequality symbol. Because that inequality symbol is a greater than or equal to, I'm going to make this a solid line. And I'm either going to shade the left side of the line or the right side of the line. And I don't have to plug in a point for this. I just have to think about it. It says x values that are greater than or equal to 5. Which side of the line are the x values greater than or equal to 5? Well, that would be on this side, where the x values might be 6, 7, 8, 9. These are the side that they would be greater. Okay, number 5. When just y is present, if it just said y equals a negative 3, what kind of a line is that? Well, that's going to go through the point negative 3 on the y-axis, and it's going to be a horizontal line. It's just a less than symbol, however, so I'm going to use a broken line. And now I'm either going to shade the points above it, or I'm going to shade the points below it. In this case, it says y's are less than negative 3, so are the y values less than negative 3 up here or down here? And the answer is down here. Okay, when your inequalities are not in slope-intercept form like these, you could put them in slope-intercept form, or we could find intercepts. I could find the x and the y-intercept if I wanted to do that. If I put a 0 into this inequality, remember we're going to treat it, to find the points, we're going to treat it as if it were an equation. So if I put a 0 in here for x and cover that up, because it's 0, if I were to divide by 3, I'd get a negative 2. So that's my y-intercept. If I put a 0 in for x and cover this portion of it up, the x would be a negative 6. So those are my two intercepts. I can plot those. Negative 6, 0 is out here. 0, negative 2 is down there. Now that's how you find the points, as if it said equals. Now I'm going to go back, and I'm going to look at the inequality symbol. Because it has the line underneath of it, I'm going to make a solid line. I either have to shade above that or I have to shade below that. Now I have to decide. I'm going to pick a point that's not on the line. Now I've been picking 0, 0, and I could do that again, but just to show you, you don't have to choose 0, 0. I could choose, like I'm going to choose 1, 2, negative 2, negative 2, negative 3 is what I'm going to choose. 1, 2, 1, 2, negative 2, negative 3 is right there. I'm going to choose that point and see if that makes it a true. If I plug that in here, I would get negative 2 plus 3 times negative 3 is greater than or equal to negative 6. This would be a negative 9. That would be a negative 11 is greater than or equal to negative 6. Well, that's false. That's not true. That's false. So I don't want to shade this side. That's a false side. So I go to the other side and I shade. So you want to shade the side that's going to give you something that's true. Okay, you can go ahead and do number 7 on your own. Okay, I just want to look at these last two here. It says what inequality is shown by the graph, and so you kind of have to figure things out. You can do that by looking at the y-intercept. Okay, find your m and find your b value like you did earlier in the semester, in first semester. So it's going to go through 0, 0, so that my y-intercept is 0. And the slope of the line, if I pick 2 points on the line, looks like these 2 points, I rise 1 and I run 3. I rise 1, sorry, I messed that up, didn't I? My b value is 0. My slope is my rising of 1 and I'm running 3. Okay, so I'm going to say y. Now instead of saying equals, I got mx plus b. B is 0. Now I got to decide what inequality to put in there. Am I going to put a less than in there, or am I going to put a greater than in there? And you just have to decide. You can't use 0, 0 in this case because it's on the broken line. So pick a point over here. Okay, that point is at 2, negative 1. Now that's the side that's shaded. So when I put 2, negative 1 into this inequality, I want it to be a true statement. Okay? So if I put negative 1, 1/3 times 2, this would be negative 1 and 2/3. What inequality symbol would be? Negative 1 is less than 2/3, right? So we're going to put the symbol less than. Y is less than 1/3 x. Okay, over here, if I did that, I want to locate my m and my b value. Looks like it's crossing at positive 1. And if I pick 2 points on here, it's going down 1, 2, 3, 4, going down a negative 4, and over 2. So that's a negative 2. So I'm going to say y, and I'll put an inequality symbol in there, 2x plus 1. Again, I want this to be a true statement, so I can pick 0, 0. 0, 0 is shaded. So when I put 0 in here, for x and y, I'd have 0. This would be 0 plus 1. What inequality would fit in there to be true? That's another less than. 0 is less than 1. So I'd put the inequality y is less than negative 2x plus 1. So you're creating the inequality for the graph that you see. Okay? Go ahead and find the worksheet on PowerSchool and give it a shot.